Hi, my name is Daniel Skutis with K-State Research and Extension. This video is an introduction into selecting and placing a pump into a pond or stream utilizing solar power. This information and more can be found in the Livestock Watering Handbook, which is found on our K-Care website. With that, let's get started. So why pump from a stream or pond? A few of the main reasons are listed right here. A big one for us as watershed specialists is water quality. We're working to make sure that the water that you have to take care of your livestock with, as well as the water that's going downstream to your friends and neighbors, is going to be the best possible. And keeping the livestock manure out of the water and into the fields and pastures where it belongs is a big way to do that. As well, animal performance and health is going to be better when they're drinking cleaner water. Cattle going in and out of the pond or streams can degrade stream banks and often can lead to the pond's lifetime being less. And to save you from having to rebuild ponds or dig them out, keeping them fenced off can make them last even longer. Before we get into it, let's talk a little bit about the pumps we use. Now, the pumps we're using are ranging from $50 to $150, so they are more budget-friendly minded and sourced from online retailers. There are many pumps available that are going to cost much more than that, into thousands of dollars, and these work very well and often do last longer, but generally we like to stick on the budget end side of things for throwing them into ponds and streams. We have got several years of use out of many of these pumps and would recommend them for anyone looking for a budget-friendly but still highly functioning option. There are two main styles of pumps we use when pumping out of ponds and creeks. Centrifugal style pumps, which are similar to sump pumps, and diaphragm pumps. The next demonstrations will help you weigh the pros and cons between the two to see which is right for what you're needing to accomplish. The first style of pump I want to demonstrate is the centrifugal style pump. Now, once again, these are similar to sump pumps, meaning they can move a lot of water. This particular style is maybe 15 to 20 gallons per minute, but it doesn't do it with a lot of pressure. The low pressure means you're only going to get head heights of 15, 20 feet, depending on the model, but the water you do move is going to be coming out at a high volume. Another benefit of the centrifugal style pump is it can handle silty and dirty water better than diaphragm pump, meaning when you put it in an old dirty pond or maybe a muddy creek, you have to worry less about the pump being damaged or getting blocked up by all the sediment in the water. The next pump style I want to talk about is a diaphragm style pump. Now, the centrifugal pump was known for high volumes of water at low head height. The diaphragm pump is known for low volumes of water, maybe 1, 2, maybe 3 gallons per minute, but at a high head height, meaning it has the pressure to push water up 100, 200, 250 feet, possibly more depending on the model. So whereas the centrifugal pump, I could stop the flow of water with my thumb, the diaphragm pump, there's just too much pressure. It can really push the water where it needs to go. Now, the diaphragm pump is not quite as good in silty, murky conditions as the centrifugal pump is. Meaning if you put it in dirty ponds, dirty creeks, you may want to put some protection around it to help filter out some of the silt and dirt before it gets to the pump. Now, one style of pump I didn't talk about today is a helical style pump. Now, helicals can move a lot of water and at a good head height. However, they're just not built to handle sand and grit and sediment that may be found in creeks and ponds. Therefore, we reserve them for using them in clean wells, old windmills that are just free of that extra grit in the water. The extra grit can get in and damage the helical pump rather quickly, causing major issues. Shown here is one of the main ways we like to put a pump into a pond or stream. Simply a 5-gallon bucket with holes drilled into it. This helps keep the pump out of the muck and mud while still providing ample water to it for pumping. Now, the hose does not always have to come out of the side. It can also come out of the top, whichever works well for your application. Here we have another demonstration using our 5-gallon bucket method. In this demonstration, we had the rope tied off and tied to the bank, and the 5-gallon bucket was placed down in the water with holes drilled in it. In this case, we could have also put a lid on the bucket and tossed it into the middle of the creek. We want to find a nice deep hole that you can put it to give ample water to the pump. We're all about recycling at K-Care. Here is another example of using something you have around the farm to utilize it in your pumping operation. In this case, a pump has been attached to an old tire, placed on an old tube, and pushed out into the middle of a pond. This is a great way, utilizing this, or quite frankly anything that floats, to keep your pump off the mud bottom and floating in the middle of the pond where it can get good, clean water out of the middle. The next video demonstrates what this looks like from the application level.
As you can see, the pump is merely chained to the wheel. It is also chained to the chain that supports the pipe. This is a nice system. It holds the pump in place well. The most critical thing is to protect how the pump wire and the hose arrive at the pump so as to not kink them or pull them out of place.
This is another type of diaphragm pump that we also use. Although this pump does not actually go in the water itself. Instead, it'll sit on the bank and utilize a garden hose and a foot valve to pull the water from the pond or stream and then push it through the pump to where it needs to be. When using this type of pump, we'll build PVC structures that are placed in the water source. In this instance, we have a riser that we often use to be pushed into farm ponds. You can see that the middle part of the riser that extends up is full of holes to collect the water, along with markings of a foot to show what the water depth is. The next video will demonstrate what it looks like when this structure is placed into a pond.
Let's see if we can slide this out. One foot, good. 2 foot, good. Look at this. It's going down. 4, 5, 6 foot.
In addition, we can even use these risers in more creative ways. Here we've attached a diaphragm pump onto the riser up above through some of the holes in order to keep this style of diaphragm pump from sitting in the mud and muck. When it comes to using solar panels and pumps in ponds and creeks, sometimes creativity is the name of the game. This is another example of a PVC structure that we can use with the foot valve type of pump. Here we have a square that's been built at the end of a PVC pipe where the foot valve and garden hose will be pushed down and used to bring back water. You can see the holes have been drilled at the top side of the square, which is elevated to keep it up out of the bottom of the muck and mud. On behalf of K-State Research and Extension and K-Care, I appreciate you taking the moment to view this video. For more information or the complete livestock watering handbook, please visit our K-State K-Care website. There you'll find links to all the information we have, as well as contact information for additional questions. Thank you.